Last time you learned that you're allowed to multiply radicals. As long as everything's under a radical, you can multiply it with everything under another radical. So say we're just going to divide. It's the same thing. The two things I have written here, the radical 15 over 5 under one radical is the same as writing it as two separate radicals like this. So those are the same no matter which way you see them. You're going to see them both ways. But since the 15 and the 5 are both under a radical, you can divide or reduce, however you want to think about it. So this whole thing would just reduce to radical 3. And since 3 has no perfect squares in it, then it's already simplified. So this is enough. Let's look at one where there's maybe more to it. I want you to always look for perfect squares. So if I take this radical and I split it up into 2, which isn't always necessary, but hopefully you notice the bottom is a perfect square. So that's going to make it super easy to simplify now. So the top is going to stay radical 5. The bottom is 3a because the square root of 9a squared is 3a. Radical 5 can't simplify anymore, so we're done with that one. Here's another one. Now we see we have some outside numbers also, or a whole number. The radical 180 and the radical 3 can still be divided, so ignore the 4. But if I have radical 180 over radical 3, that reduces to radical 60, because 180 divided by 3 is 60. And since the 180 was on top, the bigger number, the answer is going to go to the top, just like if you're reducing a fraction. And then we also have to simplify radical 60. Well, I know that 4 times 15 is 60. And the square root of 4 is 2, which would be a pair of 2's, for those of you that like the prime number. So 2 would come out. 15 only breaks down to 5 and 3, so there's no perfect squares in there. So it's going to stay 15. And then the 4 in our denominator goes back. And you also have to look for reducing numbers that are not under the radicals. So just like if that was just 2 over 4, you would reduce it to 1/2. Same idea. So outside numbers reduce, inside numbers reduce. So this becomes 1 radical 15. I'm not going to bother writing the 1 though. And the bottom becomes 2. So double check that you can't reduce outside numbers with each other, and double check that your radicals are simplified all the way. So 15 is only 3 times 5. There are no pairs in it, so this would be simplified. And then there's one more thing you might have to worry about on a couple of the problems. All of our answers so far have had radicals in the numerator, but they've simplified so that there were no radicals in the denominator. That's a big no-no. So we're going to do one that has an answer with a radical in the denominator. Okay, so there's something called rationalize the denominator. Make it a rational number. Radicals that are not big squares are irrational numbers, so we can't have those in the denominator. So here's what we're going to do. We're going to first reduce, just like we have been doing. Reduce it as far as you can, because the smaller numbers you have to work with, the easier it'll be. So I look at this and I see radical 2 over radical 6, which I know reduces. See radical 1 over radical 3. 2, 6 reduces to 1/3. Well, square root of 1 is just 1, so I'm going to get rid of that. So it's negative 4 times 1. Okay, so we're not allowed to have our answer like this. There's a radical in the denominator. Alright, so here's what we do. Whatever the radical is that's in the denominator becomes a fraction over itself. Just repeat it. Because what you're really doing now, you're just multiplying by 1, which isn't going to change the value of anything. Everything times 1 just stays the same. And so we do the top, negative 4 times radical 3. and then we do the bottom. Well, radical 3 times radical 3 is radical 9, which simplifies to whole number 3 because the square root of 9 is 3. That's your whole point. So when you take a radical times itself, you're taking a number times itself, you're going to always end up with a perfect square, and that perfect square then can be simplified to a whole number. So you have to have whole numbers only in the denominator. And then always check for reducing. We can't reduce negative 4 over 3. Improper fractions are fine, just don't worry about it, but you have to make sure they're reduced. The radical 3 doesn't simplify, there are no pairs. And so this would be it. There's also a good example in the book on page 581 of rationalizing the denominator. So look at that, and if you still need help, message me under discussions and read under there if you do have questions and see if anybody else had the same question.